Hello, 7. You do need to know the perfect squares to estimate the square roots of non-perfect squares. So that chart we made in class, you're going to want to keep updating that, keep that in your memory span here. So, first example, if I were asked to estimate the square root of 83 to the nearest whole number, I would do the following things. First thing I do recognize is that 83 is not a perfect square, so I know my number is not going to be a whole number integer. So, I say the largest perfect square that is less than 83 is 81. And I know that square root of 81 is 9. Then I know that the smallest perfect square greater than 83 is 10. So the square root of 100 is 10. I meant 100 there. So what I know from those two things is that I can plot each square root out of number line. And I know 9, it's in between 9 and 10. And the square root of 81 and square root of 100. 83 is far closer to 81 than it is to 100, meaning this number is going to be closest, if I rounded, to the nearest whole number of 9, because it's not quite halfway to 10. So what we resolve from this is the square root of 83 is between 9 and 10. Since the square root of 83 is closer to the square root of 81 than the square root of 100, the best whole number estimate for the square root of 83 is 9. So we tried square root of 23 and a half. Largest perfect square that's less than that is 16 for a square root of 4. The smallest perfect square greater than 23 and a half is 25. So my square root is somewhere between 4 and 5. And when I put it on a number line, 23 and a half is much closer to 25 than it is to 16. So I would round up, making 23 and a half, the square root of that is between 4 and 5, but I'm going to put that the best whole number to estimate to is 5. Give these to try on your own if you'd like. I may do a couple. So I may say, okay, I kind of do it this way. I do 35, I'm using the mouse again, and I know a square root that's bigger than that, a perfect square, is 36, and I know a square root, perfect square smaller than that would be 25. And I can see on a spectrum, well, 35 is pretty close to 36. So square root is 5, square root is 6. It's far closer to 36. So the nearest whole number would be 6. Square root of 44 and 8/10. Find the one that's closest to, as well as 170. Remember using that line to help you out. And using this number line here, this is always a good choice to use. Marking them 4 is the same as square root of 16, and that's why they're lined up. Real world example, the golden rectangle is found frequently in the nautilus shell. The length of the longer side is divided by the length of the shorter side. Of the shorter side is equal to 1 plus the square root of 5 over 2. Estimate the value. So first we find the value of the square root of 5. And it's between 4 and 9. So it's going to be 2 squared in between 3 squared, which is 4 and 9. So I take the square root of both, and it's somewhere in between 2 and 3. So I can estimate it's going to be a little closer to 2 because 4 is closer to 5. Okay, this is a lot more work than I would do. 4 is closer to 5. So I'm going to use the square root of 2 rather than 3 because 5 is closer to 4, remember? So then 1 plus 2 over 2 would be 3 over 2 or 1 and a half. So I'm just using that estimating and then putting it in. And notice how we have this approximately because it's not exactly equal. Pretty simple, pretty basic. Use your knowledge from yesterday to help you today. Estimating, making those number lines, and we should be in good shape. Personal tutor if you want to, book if you want to. Mr. Hoff, Miss Lentz, I do that every time. Mr. Lentz, Mrs. Hop, and Miss Griner as well. Have a good